Good morning. So we'll start with a new chapter today, squares and square root, that is session 1. So the square of a number is obtained by multiplying a number by itself, that is called as a square number. For example, a square, when I talk about, I get a square when I multiply a by itself. 12 square when I talk about, when I multiply 12 by itself, that is 12 into 12 is 144. So how do we define a perfect square or a square number? A natural number n is called a perfect square or a square number if there exists a natural number m such that n is equal to n square. This is a typical definition of a perfect square or a square number. So now what you have to do is give the heading as squares and square roots and write down this. After this you need to write perfect squares 1 to 20. And children, you need to be very perfect between the perfect squares from 1 to 20. If I ask you the square of 13 square, you should know that is 169. Square of 15, 225, right? So you should know the perfect squares from 1 to 20 by heart, what I can see. So how do you write this now? After this, you will write 1 square is equal to 1 into 1, that is 1. 2 square is equal to 2 into 2, that is 4. So this will go on till 10 square is equal to 10 into 10, that is 100. First 10 square, then 11 square is equal to 11 into 11, that is 121. 12 square followed by 20 square is equal to 20 into 20, that is equal to 400. Please do not put this dash 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 how I have put. You need to write down this in your book and please learn them. You should know them perfectly. So in this chapter we will be studying about perfect squares and square root. So the first half is about the perfect squares and the square number. There are some properties of perfect squares. Let's understand them. So what are the properties of a square number? So now when we observe the perfect square, I will just show you the perfect square number. I'll do one thing. I will write the perfect squares so that you will understand the properties of the perfect squares very well. Okay? So let's just write down the perfect squares. I'll just write 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81 and 10 square 100. And 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225, 16 square 256, 17 square 289, 18 square 324, 19 square 361 and 20 square is 400. Okay? So here children, to understand the properties, first of all, the first property tells that a number having, now let us see the perfect square number in the unit digit. So we have here 6, 5, 6, 9, 4, 1, 0. Same thing. So the property first one, if I see that the unit place of the perfect square can be what? It can be 0, it can be 1, then it can be 4, it can be 5, it can be 6, 7, 8, it can be 9. So the perfect squares can only end with 0, 1, 4, 5, 6, 9. Is there anything else apart from this it can end? No. Okay. So we have to always make sure that the perfect square ends with these numbers, unit place. Next, a number having unit place. Suppose if any number is given whose unit place is say 2, 3, then 7, 8, that means it is not a perfect square. It is not that every number whose ending is 4 is a perfect square, no. But if it is a perfect square, it has to end with these numbers. If not, no. Any number, for example, if I say 74, since it is ending with 4, it need not be a perfect square. But if it is a perfect square, it has to end with these numbers. In case if they are ending with these numbers, that means they are not perfect square. Number of zeros at the end of perfect square is always even. Now see here, 10 square. So number of zeros are how many here in 10? 1 0. Number of zeros are even. 2 zeros are there. In 20, how many zeros I have? 1 0. It is ending in even zeros. Okay, let me take 100 square. Answer is, so if there are 2 zeros ending with how many? 4 zeros. Number of zeros in the perfect squares are always even. That is next property. The numbers ending in the even number of zeros may or may not be perfect square. Example, yes. That means anything which has even number of zeros should not be a perfect square. Suppose if I just write here 1500. Since there are 2 zeros, it is not a perfect square, right? It should lie in the condition of perfect square. If then it will have even zeros. A number ending with odd number of zeros is never a perfect square. Suppose if I tell you this is 100, right? If I tell you 1000, is 1000 a perfect square? No. 1000. Looking at the number I can tell 1000 cannot be a perfect square. Why? Count number of zeros. Only 3 are there. If it was 10,000, then it would have been a perfect square. Now 25 is a perfect square, right? Is 250 a perfect square? No, because it has odd zero. Is 2500 a perfect square? Yes, because 25 being a perfect square, it has even number of zeros, so it is nothing but 50 square. Understood now this point? Next one. The unit digit of the square of a natural number is the unit digit of a square digit at any unit place of the given number. That means whenever you see that a particular digit will appear twice. That means, see here, 1 square is 1. 9 square is also 81. So that means 1 and 1. 1 and 9 will have the same repetition numbers. 11 square is 121. 19 square is 361. 2 square is 4, 8 square is 64, 12 square is 144, then 18 square is 64. Why? Because 8 8s are 64, unit place is 4. That you have to remember always. Square of odd numbers are always odd and square of even numbers are always even. Odd numbers odd. I am not saying this 4 is odd, 4 is even here. Not about that. Number of digits odd. Number of digits odd. It is odd, it is odd. 3 is an odd number because not exactly 3 when we talk about. Now see, 4 is again here, what you say, even number. So it is even. 5 is actually what here? Odd. But actually we have got here 25. What is 25? Odd number. So we are not looking about number of digits. We are looking about the digit what we get here is. 1 is odd, it is odd. 2 is even, it is even. 3 is odd, number is odd. 4 is even, 16, ending with this is even. 5 is odd, 25 is odd. 6 is even, 36 is even. So the square of even number is even, square of odd number is odd. That is what they want to tell here is. So these are few properties of perfect square numbers. Now children, first of all in your book what you have to write this. The statement what I had given, after that the definition, then you need to make a list of perfect squares. Anyways, I have done that. You have to actually write the properties also, but I haven't written the properties on the board. So what you will do, what I will do is, the properties you will get that in the video as a slide. So you can just pause it and just write down the properties of a square number. So apart from this, there are few more properties also. That is one of the important property. What we have to know is pattern of square number. Not only by just reading this we can write a square number, we can also understand that by a particular pattern, and that pattern is called as a triangular numbers. Let us see how we can find a square number by a triangular number. So, patterns of square numbers. So, triangular numbers I will write here. So, we have many patterns, like you can see we have consecutive number pattern, consecutive odd numbers, consecutive even numbers, Pythagorean triplet pattern. But what we will do here is, we only understand the pattern of triangular numbers here. About consecutive numbers, odd, even and Pythagorean type, we will do that once we are starting with the exercise sums. There and then we will understand the properties. So, now triangular numbers when I talk about, that means I should have a triangle. I cannot have that with one single dot or a point, right? So, let me draw a triangle with respect to number of points. Minimum how many points do I require to draw a triangle? I require 3 points, right? So, if I have to draw a triangle now, from what I can draw, I have to draw a triangle with 3 points, right? Understood. But how do I draw that? If I have given set of even points, like this the points are given. So always when we have to draw a pattern for triangular numbers, we have to have a set of square kind of a numbers only. From that we have to draw a triangle. So let me draw a triangle from these numbers. Let me draw these numbers a bit big. Okay. Okay, I will come to the conclusion later. This is one pattern of triangle. Second pattern of triangle, how can I draw? See here. First pattern is the same thing, right? So if I want one more triangle, that means I have to add one more point. So that will become a square of 3 points. So 3 here and 3 here, right? If I want third pattern, then how it has to be? It has to be 1, 2, 3, 4. That means I have to have 4 more points here also. Draw these dots a bit big so that we can have the pattern easily. Okay, let's draw the triangle with this. Here if I have to draw the triangle, I have to first join these points. I have to join these points. Then, of course, I can only join. This is my triangle form. Only one triangle you have to form. Form a triangle here. 1, now here. Now see where you have to join. Exactly the points have to meet. Right? We have done there. Now count the number of points you have joined. Let's see. This is 3 plus 1. Left over 1. This is 1, 2, 3, 4, 5, 6. 6 plus 1, 2, 3. Children, see here. 1, 2, 3. Again don't count 4, 5, 6. Leave the counted ones. 1, 2, 3, 4, 5, 6. Plus 3 points which are remaining over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Once again, did we miss? Yeah, 6. Sorry. See here. 1, 2, 3, 4, 5, 6. What about this leftover point? These points are left, or you can consider that point, you can consider in triangle only. Okay, what we will do here is, let's consider this point in triangle because that is used in the triangle part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 will take because that point is inside the triangle. 1, 2, 3, 4, 5, 6. Okay. Now add this. 3 plus 1 is 4, which is nothing but perfect square. 6 plus 3 is 9, which is nothing but perfect square. Next, 10 plus 6 is 16, which is nothing but perfect squares, right? That means we can find the perfect squares with triangular numbers. What pattern do we get? If we combine two consecutive triangular numbers, then we get a dot pattern which represents a square number that is here. This is how we can find a perfect square by given the dot pattern of the triangular numbers. Suppose if the triangular numbers are given, or form a triangular numbers or form a perfect square using triangular numbers, you need to form like this. It is just a forming numbers. You don't have anything much to understand here. This is the pattern of the triangular numbers through which we can form a perfect square. Now, still we can have a higher order sums here in a way, because we can also give the next consecutive number. See, this is the first triangular number. This is the second triangular number. This is the third triangular number. Means I can say my first triangular number is 4, second is 9, third is 16, like that. With those many number of points I can form triangular numbers. But here you only understand how to write a perfect square using triangular numbers. Now children, since this comes under properties, so you will have a small slide in the video itself where you can pause and you can write down the properties of perfect square. There are some more properties like Pythagorean triplet, consecutive odd and even numbers, that we will see once we start with the exercise only. There and then only we will understand that. So this is something basic information about square numbers, that is from chapter squares and square root. We are first studying about the square numbers here, and then we will go to the square root. So in today's session we covered only the basic introduction part. So in tomorrow's session we will begin with the exercise.